Hello everyone, I welcome you all to Startup Academy, your online gateway to success in the ISS exam. So, in the previous lecture, we were discussing about descriptive paper 3, which is statistics, and in that, we were discussing the topic econometrics. In this lecture, we will continue with the topic. In the previous lectures, we have done simple linear regression model, multiple linear regression model, and their previous year questions. Now, in today's lecture, we will do some problems relating to these models. Now, the models cannot be equal in every situation. Model cannot satisfy all the assumptions, Gauss-Markov assumption. If some of the assumption or one or more of the assumption are not followed by the model, then there is the problem in our model. Then we have to first remove those problems, and then afterwards we will consider that model as our model, after which we will calculate the estimators. So, today's concept is some problems with the models. There are many problems. So, first take first problem, which is heteroscedasticity. Suppose we have our model yi is equals to beta naught plus beta 1 xi plus epsilon I for all I goes from 1 to n. So here we notice that estimation of epsilon I is equals to 0 and variance of epsilon I is equals to sigma I square for all I goes from 1 to n. So for I goes from 1 to n, the variance changes. In the Gauss-Markov assumption, we have stated that variance of epsilon I is equals to sigma square, which is a constant term. But here is the case is not the same. Here the variance is changing. It is not constant. So here our problem is heteroscedasticity, which is changing variance. Now to solve this problem, firstly we have to detect whether our model contains this problem or not. The first is detection method. The first method of our detection is plotting between plotting between this predicted value of y and e, which is nothing but residual. Now, if we have been given a model y is equals to x beta plus epsilon, and if we calculate the predicted value of y, it comes out to be x beta cap. So we know that the residual is nothing but y minus y cap. So we have to plot against these things. First plot is So if the model goes like this, so here we see that as y cap 1, the predicted value of y is increasing, e is also increasing. So there is change in variance, a large variability is present, and hence we can say that this is heteroscedastic. Then again, firstly, with the changing value of predicted changing with the predicted value of y, firstly it increases and then decreases. So variability increases, and hence this is also heteroscedastic model. This one, the with the changing value of the predicted value of y, the value of e remains same, and hence it is homoscedastic. There is no variability. Here also, with the changing value of predicted y cap, we see that there is change in the value of E, and hence it is heteroscedastic. So this was the first method of plotting. Next is Breusch-Pagan test. For this Breusch-Pagan test, firstly we will take the model y I is equals to beta naught plus beta 1 x I1 plus beta 2 x I2 up till beta p x IP plus epsilon I. This is our model for all I goes from 1 to n. Now this is our model. We will calculate first we can write it as y is equals to x beta plus epsilon, and we will calculate the predicted value of y, which is y cap is equals to x beta cap. Now we will calculate E, which is nothing but y minus y cap. Firstly, we have to do all these steps, and afterwards we will move to let us consider another model zi is equals to e square, which is nothing but alpha naught plus alpha 1 x 1I x I1 plus alpha 2 x I2 plus alpha p x IP plus mu I. This is our second model. Here we can write it as z is equals to x alpha plus mu, and we can write the predicted value of z as x alpha cap. Now we will get E as E2, we can write it as E2. We will get z minus z cap. So we will get another predicted value. Now Breusch Pagan test statistic. For Bruce-Pagan test statistics, first of all, we will calculate R square, which is the coefficient of determination. The value of R square is nothing but 1 minus RSS upon TSS, where RSS is residual sum of square and TSS is total sum of square, which can again be written as 1 minus Z summation I goes from 1 to n Zi minus Z cap whole square upon summation I goes from 1 to n Zi minus Z bar whole square. We will get R square from this. Now Brish-Pagan test statistics, I am writing it as BT, is given by n capital R square. So if here where n capital R square goes from chi square p, chi square with the parameter p. Now if chi square is greater than chi square alpha p, then we reject H naught. And what was our H naught? H naught and H1, which is null hypothesis and alternate hypothesis. H naught was sigma 1 square is equals to sigma 2 square is equals to sigma p square versus sigma I square is not equal to sigma j square for all I not equal to j goes from 1 to p, which means that it is homoscedastic. The model is homoscedastic versus the model is heteroscedastic. In this test, in this Bruce-Pagan test, we test every variance of every value, like sigma 1 square, sigma 2 square. If they all are equal, then the model is homoscedastic and we accept H naught. We accept H naught if we say that our model is homoscedastic, and if chi square value of tabular chi square is greater than our calculated chi square, then we reject H naught. That means our model is heteroscedastic. Now again, moving on to third method, which is plotting residual against excise. If we have to plot residual against xi, then our model is given by yi is equals to beta naught plus beta 1 x I1 plus beta 2 x I2 plus beta p x IP plus epsilon I for all I goes from 1 to p. This is our model. Now again we will calculate y is equals to x beta plus epsilon and y cap as x beta cap, and we get residual, which is nothing but represented by E is equals to y minus y cap. Now again we will plot residual. If our values are increasing like this, then again more variability. As the value of x is increasing, the value of the residual is also increases, and hence this is heteroscedastic. If our value remains constant, then it is homoscedastic. And if our value decreases, as x decreases, the value of residual also decreases, then it is again heteroscedastic. So these are the three different kinds of test, or we can say detection method, that we can use to detect homoscedasticity. So we will continue this lecture in the next class, as we have other detection methods as well, and then what are the remedies that we can apply to make this model suitable for our derivation of estimators. Now and after that we will do a question based on this from the PYQ, as we do in our every class. Now I would like you all, if you like the video, then you can like and subscribe to our channel, and if you didn't like, then you can tell us why didn't you like. You can give us your uh, comments, and if you have any doubt in this theory, you can ask in the comment section. Only relevant doubts will be answered. Thank you.